我就2、3年前他写过，然后就把未来的
Okay, guys, I think we can start tonight's session now. So I just want to say good evening, everyone, and thank you all for joining us for the HTCA first in-person webinar. And I just want to say welcome. And for tonight's session, we have Nancy Chang here. And I believe you guys all are really interested in moving into biotech industry or maybe like starting your own companies in the future. So I think this topic will really well fitted to your future goal or future career. So my name is Adriana. I'm a first year GSBS PhD student. As a person, I worked in biotech industry before, and I'm really wanted to maybe like start my own company today. So I'm really glad I am the moderator today for this topic. So we are very lucky to be joined by Nancy Zhang over here, and she's a Taiwanese-American biochemist, entrepreneur, and investor recently. She earned her degree from National Tsing Hua University, Brown, and Harvard, and began her career researching interferons at Roche before leading R&D at Centocor, where she helped develop monoclonal-antibody therapies and the first HIV diagnostic test. In 1986, she co-founded a company called Tanox, which developed an asthma drug, Xolair. I think you guys all probably heard about it, and it went public in one of the biggest biotech IPOs at the time. And it was later purchased by Genentech for 919 million. Since then, she led Orbimed Asia Fund, served on biotech boards, now chairs of Tang Family Foundation. So with that, let's hear from Nancy herself, and please join me to welcoming her.
It is good evening, and it's really a pleasure for me to be here. I came to Houston because I became a professor at Baylor College of Medicine in the molecular biology department, and I was a professor for 7 years. And then before, and then I went out and built a company called Tanox, which was, follow Adriana's talk, eventually sold and bought by Genentech. So I retired now, but I am still a scientist. I enjoy science and I work with science, and I'm still pretty current and knowing what's going on in the scientific field, and I love to interface with younger generations, especially if you guys are interested to do an alternative pathway for your career development. So I may be able to provide some experience and also knowledge so that help you not to go the way that without sort of guidance. So today it's supposed to be very informal. So if you guys have any questions, and Dr. Lee interviewed me for a long time, and so if you have any questions, I'm happy to answer any questions you have. So here we are.
Let's see, I think we
can okay. We
sit down and then we can have a chat.
Sure.
So you came from Taiwan
Yes.
college, and then you went to Brown, and then you later to Harvard for your PhD. So I just wonder how that journey shaped your maybe like future career path. why did you decide maybe like transition from like a more academia kind of setting into like, industry? And just wanted to hear your story or any from Taiwan and here.
Yeah. So in Taiwan, I studied at Tsing Hua University and was trained as a chemist or a chemical physical chemist. But I was working X-ray crystallography. There's a lot of mathematics and computer programming. I was doing basic and also Fortran, so very early on, and Fourier transformation on NMRs and looking at the X-ray crystallography of the protein structure. And the protein that we study is coprotoxin and also ABRANE. And it turns out the coprotoxin binds the acetylcholine receptor. And that opened up the entire neurobiology field. And I got interested in the biology starting in college, translating books. And then on the plane, coming over. So I got myself into Brown and chemistry department first. So we were on the plane coming over to study. On the plane, I read a book. That's Double Helix by J.D. Watson. It's a tiny book, very thin, but it's beautifully written. I was so drawn into it. I'm like your age at the time, 22 years old, and came in really very naive. And when we were in Taiwan, that was almost 50 years ago. Xisang is my college classmate sitting in the back. We kind of grew up together. And it's very conservative and it's very isolated. I actually honestly believe whatever I read in the book, the knowledge was there. It was a very little concept between experiments, and we do some experiments, but very primitive experiments. So all these knowledges, so where does this come from, right? And so came into United States and reading the books like that, it was just very inspirational. So on the plane from Taiwan to US, I decided I want to be a biologist. And nobody says I can't. And I was 22-year-old, sometimes naive. It's actually a virtue because you're not afraid to change. Yeah. So, and then I went to Harvard. I just told them that I wanted to change. And they said to me, it's like, we know we want you, but we don't know where to put you. And the reason they said that is, remember I told you about these acetylcholine receptor, the bindings, the evolutionary of the protein structure. During those age, I was 20-year-old at Tsing Hua. We submitted a paper. And the paper, we don't know why, we submitted to Nature. And Nature accepted. So I had my Nature paper at age 20. I think that probably the reason why Harvard accept me as a foreign student. Because when I went to Harvard, there were no foreign students. Just me and my ex-husband. And there were no foreign students, not just Chinese, no foreign students whatsoever. So 13 years, we were the first one. And then with another graduate student called Sam Wu, which study very difficult single-cell biology and action potential in the neurobiology field. And I want to go into neurobiology, but neurobiology has only 4 students, the entire graduate program. one in and one out. If there's no graduation, there's no student can get in. So I went instead to biochemistry. And that's how I started the career. So during that time, interferon was the biggest project. Everybody touted the most valuable protein, and that can treat everything. And people said it's from cancer to aging, interferon can treat everything. So I naturally want to do something impactful. Again, a 20-year-old, very young, really don't know too much, and decided I'm going to find a professor. And the professor is actually at Roche Institute of Molecular Biology, and Sepeska, who is a Nuremberg student. So now Nuremberg is the one decoding the genetic code, you know, which GGG is glycine, and ACG is something. So those are all decoded by Sid Pesca and Nuremberg, and he was a pediatrician, and interferon project was his. And then during that time, we were working in a lab, and I remember I was pregnant, and he wanted me to go home. He said, if you don't go home, I don't want to be the one to deliver you. So that evening, I went home at 7. My daughter was born at 10. So I was working until the last day of my pregnancy. And during that time, I was working on interferons, cloning the interferons. And people would talk to me like, wow, you're doing, you know, things are so pioneering, you know, in other words, a breakthrough science. And I was thinking, what breakthrough? I was wearing the coat, in the lab coat, in the coat room, and drawing pipette. In those days, you don't have a kit. You do everything. You draw pipette to and dissect a frog to get oocyte, out, inject the mRNA into the oocyte to do the experiment. You want to have a protein standard, you kill a rabbit to get muscle cells, muscle proteins. You get fibrins to get molecular standard. You want to have P32, you make 6-phosphate exchange reaction. You want to restriction enzyme, you purify yourself. So I did all those things in the lab. Purify EcoR1, HindT3, XO3, and actually provide the material to local companies. There were 2 local companies, by New England Biolab and BRL. So I was not even finishing up. The BRL president is Steve Turner. Now this later on became CEO of Life Science, offered me a position. He said, do you want to come over to our company and to be the vice president on research? I ran away. I said, what is vice president? So that's how the career actually went. So it's very, maybe lucky, but also I was a kid that can do a lot and willing to do a lot. And so I got exposed to many things. And I was not afraid to, became a biologist, and was not afraid to go to an industry at the time. And no one was in industry. My professor at Harvard actually said to me, which Harvard student ever go to industry? The good science and good kids are all in the academia. But I went to Roche and working on this major project, and we succeeded. We actually cloned the alpha-beta interferon gene on the same petri dish, the same day, and it became the drug. We purified the interferon. That was another incident that worthwhile mentioning. So Roche had two parts. Nutley, that's where I was, and then Basel, Switzerland is another part. And the counterpart over there is Theo Staley. And Theo Staley, if you are scientists at my age, you know Western blot, Southern blot. He was the first paper published. Western blot is what he called. He was the inventor of the Western blot. And during those days, Roche has one scientist called Neil Jern, and he was retiring a few weeks after I had my child was born, and the molecule was cloned, and we wanted to prepare something unique for the professor who was a Nobel Prize winner to retire with this protein. So Theo and I was working in the lab, and he prepared the antibodies for interferon and pulled it over, and we purified it. So on Neil Jern's party, which I couldn't go because I just had a baby Friday night, and that was the next Wednesday, and Theo presented the 1 milligram of purified interferon, which are worth about a gram would be like $1 billion at that time, and give it to Neil Jern as his retirement party. But the next day, if you would know the history, the next day, New York Times, front page, Genentech, David Godel says they cloned it and they purified it. Went on, but it wasn't. It actually the Roche scientists did the work. But that was the precipitated to how Roche and Genentech formed the partnership and was the interferon project. So that's the history.
Yeah, that's amazing to
Yeah.
hear.
So it was lucky, maybe it's lucky, right?
Yeah.
That I was in the right place and I was only 20-year-old. I don't know. When people says you're cutting edge, that's the word they use, cutting edge technology. I was being interviewed by newspapers and all that. I'm just thinking, what cutting edge? I'm in the cold. My glasses fogged up all the time. I was drawing the pipette. What is cutting edge? So behind the cutting edge, everybody's seeing the work. That's a lesson for you. The work is mundane. It's tedious, it's mundane, it's work. But on the outside, it's shining, it's exciting, it's the cutting edge. But when you're really doing it, it's step and step and step. So that I can say for everything that I have done, that it's a lesson.
So after your time at Roche, you went to Centocor, right?
Right.
What did you do there, and why did you decide this transition?
Well, that was interesting because I was actually at that time was kind of become well known. So then a lot of offer came. And I think the Phil Sharp from MIT and actually told Sharon Fowl, says, this is the girl you should hire. So I actually won the interview because we beat Sharon Fowl and won the interferon race. Yeah. So they offered me the head of biotechnology. I was 28 years old. I had no idea what that means. I said, I can't have the job. It's too good to be true. He said to me, the guy said to me, I never heard about anybody will turn down the job because it was too good to be true. So the reality is I was scared. I mean, I don't know what that means, being a head of biotechnology. I never done it before. I don't know what to do. And so I turned it down the job. Instead, I went to Centocor. Centocor was just in the beginning, and joined the founding team and being a bench scientist. And that's where I learned to do the diagnostics. And then I also pioneered it, making the antibodies that made the transition of Centocor changed. from therapeutics from the diagnostic to therapeutics. So then the chairman, I had a very good boss. They're very young, but they were good. They somehow recognized that I can do things. So they allow me to actually venture into the antibody field. The company was not making antibodies at the time and was using antibodies to do diagnostic assays. We did develop quite a few assays, and these assays, surprising until today, still the gold standard. For instance, the CA-125 for ovarian cancer. Bob Bass and I, we were working together. He was a young Harvard professor. Okay, identified the CA-125. Later on, he moved to different universities and then even MD Anderson, head of medicine. And even at MD Anderson, we tried to find new things for ovarian cancer, couldn't. So CA-125 stay until today are the gold standard for women detection of ovarian cancer. And also do 99, that was GI cancer, 17-1A, breast cancer. And so we did diagnostics, but diagnostics is very tough. So I don't remember many things now, but the detail stuff. But I do remember every 4 years, you've got to make a new one. If you don't, then it doesn't work. It has to retire, except things like CA-125, because nothing else better ever came out of it. And, but all the other assays, you kind of have to develop new assays. Once the one that launched in the marketplace, and a few years, and the sale goes up and then peak down, and the new one comes up. And so the company at that point was like $50 million company. They just can't get bigger. So we have to make change. So the idea that doing a therapeutic antibody was being welcomed in the company. And then we actually started working on chimeric antibodies, and then later on humanized antibodies. And now antibodies, how big is the market? 300 billion, something like that. But at that time, no one does that, right? And so that was another pioneering job that we at Centocor did.
So you kind of started your own project at Centocor to do the
Right.
monoclonal antibody work.
Right. Yeah, I remember that. How do I actually get into really the business side is another interesting story. So the lesson there is that when the opportunity hit you, it doesn't come with a package. It doesn't tell you this is an opportunity, but it is later on an opportunity. I was actually troubled with the chairman and my boss, the CSO of the company, and CEO who visit. I don't remember the meeting, but I remember my boss was very arrogant. He graduated from MIT and at Baltimore as the professor. And he's very smart, but he's also very arrogant. So the other guy says, if he's in a room, I'm out. My boss looked at him saying, you heard the man saying the door is there. So he was out. So then the boss looked at me. Nancy, you're on. So that was the first business meeting I attend, which I have to speak. Organize my thoughts. Before I was just listening. Now I have to actually on the job and giving the talk. So, and that now since I have to talk, I have to listen very carefully. Then I listened to my boss. He was saying all the things that we have not done. But he was promising that we're going to do all those. So I went back home thinking, my God, all the things I have to do. So I went ahead and do all those things. And because of that exposure, then the boss opened the door, let me then went out and participated in other business meetings. And so I was lucky again. Centocor turned out to be a really successful company at the end. And J&J bought us for $6.5 billion. And the biggest drug is infliximab, the anti-TNF antibody. But the first drug actually failed. The Centoxin failed. Then RealPro came. The RealPro is still on the market. It's Lilly. And then it's the infliximab. But infliximab became one of the biggest drugs. Still today, after all these years, billions and billions, right? So in a way, J&J bought Centocor, but Centocor really took over J&J. Not the whole company, but the J&J, the Janssen Pharmaceuticals. So because the drug is so successful at the end, treating. One of the biggest drug is Humira, which is the next generation from Abbott, and which is another version, humanized antibody of TNF. So that's even bigger than the Centocor drug. So that's the kind of the Centocor journey. So I always say that I graduated from the Centocor School of Management. And I was there, I willing to do a lot of things. I had a really good boss, and I didn't have to leave, but I guess my ex-husband wanted to be a professor. So that's why I came to Baylor as a professor, because I was a dutiful wife. And he wanted to be a professor, so we come to be a professor. Yeah.
So moving from Centocor, you became a professor here.
Yeah.
So it's kind of a big change.
Right.
From
my salary was high. My salary was high in the industry. And the first thing going to Baylor, cut in half. Several weeks later, cut in half. That's Dr. Melnick. So, but you know, we get by. I was a professor, and I was happy to be a professor.
What kind of main project did you work on during the time?
At that time, I was working on HIV. That's probably some of my best work. By then, I know that the Centocor the most senior management knows Nancy Staring. So I went. First week, we saw young people die. We don't know why. I talked to Mark. What's his name? The Yale, the Cornell professor, Mark Kaplan. He was the first doctor beginning to tell us young men die. And we don't know why. So I went to Dr. Gallo's lab. Remember Sid Pesca, my postdoc advisor, who happened to be actually Bob Gallo's advisor too. So I went to Bob's lab, and I said, I wanted to work on HIV. And nobody knows what is HIV. We just know young men died. Die of what? So we're beginning to think about how we can actually understand this mysterious agent. So that was the previous pandemic. And so I got to know a lot of infectious diseases professors at that time. And then I did an experiment. The high-end side, again, hindsight, it's clever. What I did was I said, if we don't know what caused this, then how do I detect? We know that they are in the blood, right? So then how do you create some agent that can detect the virus? So, speak more loudly? Okay, I will speak loudly. So tell me if you can't hear, yeah? So at that point, there are some DNA fragment being cloned. And we call it HTLV3 because it's affecting T cells. And then they were HTLV2, HTLV1, and that was I was a virologist. So they were infecting the T cells. And HTLV1, HTLV2 are RNA viruses. And some virus fragment was purified and isolated. So I got a few of those peptides, those DNAs, I sonicated them. And then I put them next to a beta-glycosidase. Now you got a fusion protein. Then I put the blood on top of it. Then what happened? Western blot. And you see the light coming up. So even though we don't know the virus look like, we cannot see the virus. I was able to detect the virus. And that paper published in Science magazine. And the protein become very famous called P21. It turned out to be a fusion protein out of P46. 121 of P46 is the envelope protein, and it's a fusion protein. And I remember Danny Bolognese from Duke and asked me, and I was so generous to give him 5 milligrams of the protein purified, the P1, P21. Later on, he built a company called Chimera. And today, the president of Duke is actually Baylor president's wife. Oh. And Danny Bolognese is a pioneer at Duke, and the company, because of him, Duke now has these all commercialization programs. But that peptide was mine. So that was a really nice piece of work. And later on, we got the virus, so we sequenced the virus, and I filed a patent. So that's another story, kind of interesting. So I remember we were doing the sequencing work in the lab, and to get those virus fragment or the virus pieces, I drove to NIH and got the HIV that time, and we still call it HTLV3, and drove back. It's on a Halloween day, and passing through the one bridge, somebody dumped all the white paint into my car, covered that was very scary, yeah, for me, that there's a paint dump on the car. I drove home. I want to bring that files into the lab, and it turns out that somebody in a company tell the boss, Nancy is doing HIV, or these virus can kill people, and nobody wanted these vials. I put them in my refrigerator. So from there, we sequenced the genome, and without knowing, we were working really hard. I actually told my boss, I don't need you to come back to pat anybody's back. We run a SWAT team. No weekend, no holidays, nobody get off. And we sequenced it And one day, I got all the sequences on the film and showed it to Hubert, my boss. And Hubert, I remember him. He take the film. He said, "Kiss the film. This is going to make me a lot of money. Go file the patent." So I literally took the data, went to Boston, because that's where the Hamilton Brook and Reynolds law firm was, in Lexington, Massachusetts. And when I landed, at those days, you don't need to bring IDs. I landed, I realized all I had was the data. I don't have money. I didn't have any identifications. I can't go anywhere because I don't have anything. So I pounded my watch to a taxi driver. And so I said, "You can take this watch and take me to Cambridge," because I used to be at Harvard. I still have my bank there, the Cambridge Bank at Harvard Square. And I went there. It turns out to be Memorial Day weekend. The bank is closed. So by then, the taxi driver is asking, "Where's the money?" And I don't have anything. So I borrowed some money from him, and there was no cell phone at those days. I went to a payphone, called David Brooke, and he talked to the cab guy and says, "This young lady will pay her bills, taxi fees, you drive her to Lexington." So I went there and filed. It turns out this is the patent of the first patent in the world on HIV. Today is a patent that Mr. Reagan gave us 50 years. So I'm still getting royalty payment. But that was only me and Centocor those days, the patent. So when I had a Baylor, the Secretary of Health, called Lower Harmison, came to visit me all the time, quite a few times. Every time he comes, I close the door and cry, because they want to take my patent away. I fight it, and everything I want to do, the project got taken away. Other people's name get added. I actually discovered the packaging sequence. We isolated a virus called HBLV. And, but my boss told me, Baylor boss, Dr. Melnick, "You can't fight with the government." So, okay, I gave it up. When I gave it up, I talked to Tony Fauci. I said, "You can never say anything bad about Nancy." Became the patent of 3 names: me, Bob Gallo, and Flossie Wallstall. Belong to the USA government. It's a government patent today. And as a citizen of the United States, you're only allowed to get $150,000 a year. So that's what I got. The royalty payment that Centocor allowed me to have. So that was really a nice piece of work. I always treasure that. But as a young professor here, I was devastated. That was my work. The project and all this, who will know in the world? So I got so frustrated. That's why I started the company. I had to move forward, right? I have to move forward. It's just too tough for a young professor, kind of lost everything that you think you were doing, that is all taken away. Years later, Bob Gallo saw me and he said, he said, "I underestimate you." So because he want to move me, not even doing that, he want to move me out of here, go to Bethesda, Maryland. to work in his company. I said, Bob, if you really like me, why don't you give me a job I can refuse? You make my life, I can't live. But on the other hand, that's another opportunity. When something, the door all closed, the window all closed, well, there's another door open. So that's how I switched. I just, okay, stop HIV. For many years, I didn't work on HIV. So I stopped, I switched, and it turns out my ex-husband had an idea. And the idea was a little bit crazy, but he woke me in the middle of the night and says, I had an idea. I said, well, who could tell me about it? So he said, how about we develop allergy treatment by making an antibody against IgE? That was a very novel idea because the textbook actually says anti-IgE is a potent allergen. People are using it for positive control, and you want to make an anti-IgE to treat allergy. But that's sometimes creativity needs originality. And those original ideas has very delicate intricacies. Most people read the paper, look at the things, did not see the beauty of it. You cannot make just an anti-IgE. You have to make a special kind of anti-IgE. That's the cleverness of the invention. That's why Xolair today still don't have any generics because people don't know how to make it. Unless they tell me, they ask me, I can tell them. But they can't make it, right? And so, we started making start thinking about having the company. And that's the original idea, and that's the circumstances. So for one, I didn't want to have a company in the first place. But since all the doors are closed, that will be the window that opened to shed the light. And it will turn out to be a great idea. And the rest is history. So Tanox became very successful, and the drug is on the market. But Tanox is a very special company because it was built by us, the scientists, that actually respect science, love science, wanted to do beautiful work. And so not only Xolair was a drug, but just recently, this year, 2024, lebrikizumab, now approved by Lilly, by FDA, is a Lilly drug. It's coming from my lab too. And so that will be a huge drug, I predicted, because the data looks better than Dupixent. And so Dupixent sold for Regeneron for $13 billion a year. So this actually better, has results better than that. And so sometimes, again, you think it's the end of the world, but maybe the God gave you another door to open. And that was actually the beginning of Tanox. And Tanox, the beautiful thing about Tanox is I trained a whole group of kids. All of them are very successful, most of them. And the most successful one is Ed, who are now WuXi's CEO. And then the next one is Henry, who sold his company to Danaher for $9.6 billion. So all these are kids that became very successful and became the R&D head of AstraZeneca, MedImmune, global head of R&D at J&J, are all Tanox, ex-Tanox people. So nowadays, the people coming out of industry can actually go in to a small company, at that time, and I actually went in to run very major corporation R&Ds. And so I think that's why I said to you earlier, I said that the opportunity when reckoned on you, it doesn't come in with a package. It doesn't come with, you got 15% salary increase, people are congratulate you. It's not. It's something that you will do that eventually will bring that success and pleasure and satisfaction and fulfillment to you. And so success is really a journey. It's not the outcome. By the time everybody congratulate you, you think you're successful. Like me, I'm already going to the next thing. You know, whatever that they congratulate me is what we did before. And so life goes forward, and success is really a journey and not an endpoint that you pursue.
So the work for Xolair actually happened here in Baylor, correct?
It's happened in Houston, not at Baylor. So I actually had to give it up. So when Tanox was formed, my old boss actually gave me $1 million a year or so, but I had to give back all the money because now there's a company that I want to build. I can't take their money and use it here. So I actually give it back. And then we basically started a company with nothing, no money, just an idea.
So how do you go and raise the funds like?
So again, I think I was lucky. So I think to build a company, let me say it this way, to build a company, you need a multiple component, okay? Like you, I didn't come out the industry. I work in the industry before. I graduated from Centocor School of Management, right? And so I've been working on the bench. I've been talking to investors. I got my own reputation. So I was lucky because Centocor journey was a successful journey. And that successful journey built me the reputation. But I did went back to Harvard to get my professors. And so again, sometimes luck is everything. So he talked to his friend, and his friend is Moshe Alafi. The Alafi Capital is actually a company, a venture capital company, started, maybe it wasn't so much of Genentech, but Biogen, Applied Biosystems, Amgen, all those are Moshe's companies. So my professor talked to him and took him about a couple months, came to see me. But during that time, there was a reporter at Wall Street, name is Marilyn Chase. And I think it's 1987, July 22nd version of Wall Street Journal. And Marilyn Chase wrote the big article, business section. And their quote, Brett Goldberg says, Nancy, say, when are the two smartest kids from Harvard? That's lucky. Later on, because I asked Fred, I said, did you know you say that? He said, a little bit overstatement. But it's in print on Wall Street. So I got a lot of attention from Wall Street and the venture capital world, and I was at Centocor as reputations. So I raised the money that way. And there was a lot of naivete still, but today's short, so I'm not going to go in there. But Moshe had a meeting with me, and after the meeting, he wrote a check, $6 million. That was my first raise. But I did take the $6 million. I actually returned it. Because at that point, I had quite a few VCs wanted to participate. And I didn't want to just people, the whole company to him. And so I was hoping to get all together, but they can't, they don't make syndicates this way. They do syndicates on their own. And so at the end, Moshe took the money back. And the next day I got a Federal Express package. He said, $6 million, young lady, the $6 million is here. And if you don't take on Friday, money is off. So now I only have a few days. I call everybody. I couldn't get the things together. So I took 4 million, still with the hope that I can get two other $1 million from somebody else. So that was the 4 million that actually started Tanox.
So did you co-found the company with someone?
Yeah, with my ex-husband. Say when? Yeah.
And without the science, how did you? So you guys got the $4 million
Right.
and then moved down there and then built the entire thing.
We-
How do you
we
know it would
work-
work?
We started the company, so I have a little lab outside, and not at Baylor, outside, and we started working in immunize the work. And the first set of data we got, we think the idea is correct, and so that's where I actually left Baylor and become full-time in the company, and then I raised money as the CEO of the company.
So what kind of qualities do you look into, like co-founders or like early members of the team?
So I think all good companies, all good product coming with good science. So I think science has to be solid. And then you have to have people really genuinely interested in science. And also commitment has to be there. I have quite a few very good scientists. One particular in mind is Michael Fung. So Michael was an assistant professor, was already at Baylor. And when I had a company, he had a boss who was not very nurturing. And so I had to take him with me. So that involved another episode that's how Baylor trying to recruiting us. And so I came in initially as the Institute for Excellence for Biotechnology and as a director. But that didn't work out, so I actually ended up at molecular biology department. And during that time, Michael was, I would say, unfairly maybe damaged. So I said, Michael, why don't you come out and we'll work together. So Michael stayed with me. And Michael, couldn't speak a really good English. He's coming from Hong Kong, but he really likes science. And he worked real hard. He actually gave me a couple drugs. I think the lebrikizumab was his idea. And also, he works on the HIV drug. Eventually, we do have an HIV drug. It's called Trogarzo. It's on the market too. Michael actually worked on that project as well. I also have a young man, Bob Hamilton. So Bob was leading the anti-IgE project, and he actually later on changed his passion and want to be a professor. So he then moved to Johns Hopkins, and we did a lot of work with him at Johns Hopkins because Ishizaka, who invented IgE, who discovered IgE, isolate IgE from people, was at Johns Hopkins. We did a lot of key work with Bob Hamilton. He became a professor there. And then Francis Davis, and then we had a really good scientist In particular, I wanted to remember they're still alive today, Bill and Cicely's son, two or three, and then Ray Liu. Those are my very early employees. And Bill and Cicely know cell culture like art. They're so dedicated, so particular, very clean, but they do have particular real skills. So I think they made a huge contribution today in mainland China. A lot of the mainland China antibody drugs are made by him and sold. Other people could then later on buy the antibody from him. But they made all the antibody for us. And they were technicians that working with them later on became MD Anderson professors. And Mason Liu, for instance, are some of the really expert in the antibody field. So when I working with this team, I gave them 20%, 25% time, free time. I said 75% of the time you work on a company project, and 25% of the time you think. And when you have a project, you want to bring it to me, you want me to support it, I only ask you to do one thing. Are you the best in the world? If you're not, then don't do it. If you do it, you want to be the best in the world. So those are the true lessons I gave. Another very notable lesson was when they bring me a project, says, this is the HIV project. They said, we need to build a plan to make this antibody because it works, neutralizing all strains and everything in the lab. So I said, okay, how much it takes to build a plant and how many patients we can treat. It turns out if you spend $20 million to build a plant, you can treat 500 people because it's high dose. You need a high dose. And those days, the best cell line producing antibodies from Genentech was about 100, 120 milligram per liter. And they built a plant for 100 million. And so I said, no project. And I said it to a young man, the Rice Ph.D. name is Dr. Lee. And he was funny. He came to look for a job, and my VP of manufacturing was George. George said, do you have PhD? No, go get a PhD. The kids actually went back to Rice and get a PhD and came back. And so then the HIV drug we were developing. And I said, unless you guys can get to 2 to 3 2 grams per liter, don't ever come back to me. The project is dead. If in 6 months you can make it happen, the project is dead. They said, Nancy, it's tough. No project. Unless it's 3 grams per liter. Now it's only 100 milligrams, that's 30-fold. When you tell the kids say no, you actually push them to invent. So think about this. Invention coming not because of you just want to invent. Invention comes because there's a need to invent. You're not satisfied with what you have. Therefore, you have to make something new. Then the kids went back. I call them my kids. They went back to the lab working. Not even 6 months, they came. 3 grams per liter. Done. Tanox was the first company in the whole world can make antibody at gram per liters. And that's why all my kids in the manufacturing side are later on become Pfizer's head of manufacturing, Abbott manufacturing, Amgen's, Genentech, you name it. they were all very senior there. And Tom Denson was the biochemist. He later on lead Amgen's. He made 15 gram per liter over there, not with me. So now antibody can actually mass producing and benefit people. The Tanox manufacturing team was top of the world. So I had these kind of people working with me. The company culture was beautiful culture. You look at the company, it's 24/7, it's working. The reason that we have the Xolair successful, we were do parallel labs, and our lab with George, and also Martin Kunzi's lab at Switzerland. Their cells just keep dying, our cells going. And because the cells still needs feeding in the weekend, and we were there working on the weekend. And Peng Zhen, that was my student, he always worked at night. 5 o'clock at night, he comes working all night, and morning he goes home to sleep. So, but we had 24/7. We were free, and it was just a beautiful culture. Too bad, you know, when companies sold, no one actually in Houston recognized, and that's why Tanox still maintained today, maybe one of the very few successful companies ever built out of Houston. It's this culture, this idea, this passion, and the people that build. So you ask what kind of people? So these kind of dedicated scientists that we have in the company. I still have the passion, can do it, and I haven't, you know, I'm still formulating my ideas, but I love breakthrough innovations. You know, in 2001, we started a project called Rice Business Plan Competition. And today, 25 years later, this is the largest event in the world. Fortune magazine has followed us for 10 years, and we gave the top prize. In the beginning, the top prize was $10,000. This year, when I was a judge sitting down, I saw the team from Michigan University, 2 girls and a boy. They were so cute, and the work, it was beautiful. I thought, healthcare, no one will give them a prize. So I add a prize, make sure they get something, specified a prize of Nancy Chang to the team at Michigan. It turns out they won everything, so that these kids walk away with over $1 million, more than that. And so I still love science and breakthroughs, and excited when the kids see that. The Rice Business Plan competition in the 2000, that was 10 years ago, 2015, and was a young man that I'm gonna see him next week. He's in Switzerland now. He was a company called Mars. They're from Germany. And later on named called Adhesives, and Gurenthal bought it, them, and we actually got a very good return. And his name is Alex Xolair. And he was just a young man, very energetic, but has charisma. And you just knew, you know, this kid will go places. And this year, the winner, Charlie Childs, it was a girl, but her name is Charlie. She's energetic, and she won the first prize, and really just do beautiful work. It's a postdoc from University of Michigan, teamed with a graduate student. And I was surprised that Baylor don't have any applications. Rice has, and it has medical field, has, so I encourage you guys, check into the Rice Business Plan competition. and enter, if you have an ambition to be a company, then enter it and learn the skill how to make presentation, how to write a business plan, how to do the presentations, right? And so these are actually next door to you. Has been there for 25 years. I have my company, everybody be the judges there. So there's an opportunity there. And the kids have it. I can tell they have it. They have the fire. It's like Charlie, I asked her, what's fun? She said, win. I remember she, told me in the back of my car, it said, win. So that's a good spirit, right? So I wanted to see young people successful. But sometimes in the institute, you may or may not have professors wishing you successful like that. So that's the environment. It's like Tanox, we want everybody to do well. And at the end, everybody did well, did good. Some many more successful than I am. But I happy. It's just like Henry sold the company for 9.6 billion, has private planes. I don't have it. But I just called Henry and have Henry helping another boy in Seattle, has a company over there called Novel. They are in the same field. I said, Henry, go help Hakesh, is his name, and they met. Henry, well, go and help the kid. So maybe he'll be successful. So that's the people that you want to be with. Exciting, passionate, committed. And money is not everything. Money comes with the success. Money is not the first priority to chase, but it comes. That makes sense?
Thank you for sharing your
Yes.
story.
Right.
It's very incredible. You say it's luck, but I think you are the most important role in this whole thing. Your ability is definitely outstanding.
Yeah.
So
God maybe make me differently. I think a few people when I growing up, including the chairman of Baylor, Dr. Melnick knew. So when I came in Baylor, again, I was a young professor. The school only gave me nothing because they didn't recruiting me, they recruited my ex-husband, right? So I don't have the starter grant and all this stuff. And so I have a very little money, and I was given a lab in the 6th floors of a Jewish building. And so I told Melnick, I said, I can build a lab much more efficiently than what you're paying for. And I will make bench differently. I will buy the old carpet remnant, which only take me $67, and you have to pay $1,800. Can I do it? You know what he said to me? My chairman. I don't know whether you'll find a chairman like this. He said to me, okay, go do it. But do it on the weekend, close the door. Don't tell anybody. And so I did it. I got my brother-in-law, neighbor, everybody coming, nails, everything, and painted, make the bench at Baylor. Dr. Butler at the time was the president. Next week, I got a call under the carpet. How dare you to do this? This is a union. So I apologize profusely, but my lab forever looked different. So for one thing, that chairman knows I'm an entrepreneur. I may be knowing it, maybe not knowing it. It's just a kid trying to solve a problem, right? I was 34 years old at the time. how many of you are 34 and younger? Probably all. Yeah. So I had a chairman who was actually let me do things.
Can I ask questions?
Yeah.
Yeah, so I think now we can move on to the Q&A session. And we welcome in-person ask questions. And we also gather some questions here online as well. But if you want to start, you can just jump in.
Before coming here, actually, I Googled your name and I saw the video. It's an interview.
Yeah.
So talking about a whole story.
Right.
From National Tsing Hua University and
Right.
all the way to today. And after I saw this video, I felt like you are thinking, I thought my first question before coming here, I'm going to ask is that, what is your priority when you make a decision? Because like it seems that, for example, in Harvard, right, and your advisor say, Nancy, all the scientists that go to the academia instead to go to the industries, right? And then when you in Baylor, then you choose the path to industries instead of like staying there.
Academia.
Right. So I think like they have some priority you have in mind, which is totally different from the majority of the people. So you make this path. But after your talk, I think like in a Baylor, because all the doors are closed except that one's open, so you go there.
Jump in. Right.
Yeah.
And Bob Gallo actually said, I underestimate you, right? So
Yeah.
yeah.
But I still want to, because I think including me and all of us, we are on a one-way road, right?
Right.
It's life. So when you try to make a difficult decision or want to make a decision for your career path, what kind of things do you have in mind to do this kind of priority?
Well, to be an entrepreneur, number one, you have to be glasses half full, not half empty. You see all the possibility in the world. You see all the positive things in the world. You don't see not necessarily the negative things. So you need a balanced person on the side for sure.
Mm.
Because people like me, I see possibilities, opportunities, even now. But I know I'm at my age, I shouldn't be doing this now, right? Because drug development is 20 years journey, at least 15, 13 years. And it's a very long commitment. And so, so that's number one, you're positive. The other thing is impactful. I always want to do things that, you know, if I want to make money, I can make me too drugs. I don't make me too drugs.
Mm-hmm.
I do new things, new breakthroughs. I was telling Dr. Lee, a car coming over, I said, I love cell therapies because cell therapy cure disease, not just treat it, cure. So I actually like to see impact. I like, I give a lot of money to Baylor. And, but I see the impact. I've never regretted, but I wanted to do things more impactful. But sometimes the environment may or may not conducive. So then you have to think about different ways. I was telling you, I'm thinking, right? So I haven't told anyone about what I'm thinking yet, but it's along that lines. I've been looking at even philanthropies. Philanthropies, there are multiple ways you do it, but there are ways you have very big impact, right? And there are ways they're not so big impact. And so, and then when a project like this coming to you, like Baylor or MD Anderson usually show me a project. When you those projects, you have to think about it. Is it the most impactful way to do this or not? And so I'm still looking at that way to do impact. But then it needs people, right? That if you don't have the right people, all the money in the world doesn't make a success. No. the company that raised the most money are not necessarily the company will be successful. The route will be easier. But the success actually created by people or in a group of people. They're on the same boat. They're going to the same direction. They don't fight, right? And so have a company, the CEO, we talk about raising money. We talk about passionate, right? And then we talk about CEO need to be able to tell the story. You have to tell the story in the worldwide the right business plan I want you to go. There's an elevator pitch that you only have 30 seconds to tell the story. Can you actually take your whole company and distill it into a few sentences and tell how important it is? Right? And when you ask questions, how do you address the questions? So all these are skill sets. So a company successful, you need a different skill set. Tanox is very unique. I don't think I can recreate that necessarily because the people at that time was the combination of the people is make the magic. And then the other thing will be you need the conflict. There are always conflict. You need a person, and if it's the CEO, they be able to manage the conflict, manage the difference, and then make decisions, set priorities. So all these are important skill set one need to have. And then lastly,
有，你
ability
吓到我了哦。
alone.
你们的东西都拿了吗？
If you have all these
哦，不然我就说楼上。
quickly, I think
你还有什么东西要拿吗
the major
？Yeah, I
part
know. I'm just making sure 你现在有带你身。
yeah.
So you mentioned you started off in chemistry, physical chemistry, and you made a couple of different transitions across disciplines over time. I just wanted to hear your thoughts about your experiences and your opinions about different disciplines, and maybe how we can be siloed in one science versus another, and maybe what emerging disciplines that you're most excited about.
Well, I not only in graduate school, even in my career, I switch from industry, academia. I run a fund. I was a fund manager on Wall Street, right? And so, so I think you just have to be daring. But let me tell you this: when you make the switch, don't think you can come out and just start the top. You have to earn the respect stepwise from the leader.
Do you feel like your experience in other disciplines has been a major advantage for you in thinking about things differently and coming up with ideas that other people without that perspective might not have?
There is an advantage of that. But most important thing is when you can do those switchings, you're confident in yourself. That confidence, assertiveness is everything. You have to be confident, yet you're not arrogant. You see me arrogant? No. I'm just about as easy get along and friendly and warm as you can be. I don't have big ego, because the more you know, the more you know that you don't know. The people, the ego, control-oriented, obnoxious, because that's what they need to be. So.
Thank you.
Yeah.
Thank you so much for sharing your experience. It looks like you've switched across these fields and you've been extremely successful.
Can you speak a little louder?
Yeah, you've been so successful even after switching fields many times. So could you walk us into your thought process when you're switching, at the point of switching? How would you evaluate that I'm likely to be successful here, and maybe these are the things I need to do? How do you do that?
I am a super hard. You see the duck? I'm doing this. You don't see it, right? I'm a hard worker and a very solid. I don't do things halfway. I understand. So same thing as when I make investment. I will ask the founder, why? How this, right? And the kids are working with me, Max, who's so smart, smarter than I am, I think. It's one of the smartest cookies. So hard worker, really know, have the real knowledge and truly understand. And then the other thing is being passionate. You really need to. This is not an easy path. Biotechnology, you can make money so much easier. This is a hard one. Yeah. There's no easy route. Any questions?
Yes, thanks for sharing this incredible story with us. Since you have really like rich experience, you go like industrial and also academia and also the startup. So I want to know like what do you think is the biggest difference between like industry and also academia? Between these two.
Academia, you focus on grant. You have to write grants, you have to write papers, you have all this. Industry is about protecting the IPs. You got to have patent, right? So that's a major difference. The other thing is industry, academic, you get curiosities. There's always a better way to do things, but in industry, you have to cut it. And then bet on the one that you're betting on. In academia, you can have one topic and the rest of your life, you can write grants. After grants, even if you're unsuccessful, you can still write and you can still get the grants. But industry, no. You have to be accountable. You took other people's money. You can't just disappear. You can't just spend it and says, I need more. If you do that too many times, you won't be successful. No one will give you money anymore. And so you have to be accountable. So.
Thanks. That's a really answer. I do have another question. So
yes.
I want to know like, what do you think is your biggest strengths or advantage to support you like go with this long journey? And what's the biggest challenge you can remember with this whole journey you ever faced?
I think there's a lot of sacrifice I've made.
Mm-hmm.
Those sacrifices are sometimes irreversible. So balance of life may not there because nobody, if you're CEO, nobody can understand why you can not do your job right. It's hard for me to say that to you, but that's the life. That's the choice, right? So those are the hard decisions I have to make. And at the end, it's not all shiny. I can tell you the sleepless night I have, stuff like that. But if that's what you wanted to have career-wise, then go for it. Sometimes you don't have many choices, right? That went in. And the other thing is passion. You really have to be passionate. Because if you don't believe it, who else will believe in you? You started a company with nothing, no money, no patent, no team, no nothing. So how do you convince anybody to go with you? Yeah. So all you have is the way you tell the story. You convince people to come and work with you. And little by little, you build. Nowadays, it's a little different. Nowadays, the way the company build, and especially VCs like Flagships and Third Rocks, and they're incubating inside. And they recycle the CEOs. It's like a factory now, right? They put it all together. They want. Some company raised $1 billion, like David Baker's company. David Baker's company in Seattle. There you go. Yes. Yes, you first.
Thank you for sharing your stories.
What?
Thank you for sharing your stories.
Oh, thank you. Thank you. Yeah.
It's very
Happy.
incredible. And I have a naive question is that if I have the idea and I want to start a biotech, who do you think I should talk to the first one?
Well, if you're Baylor, you could have talked to your technology transfer office, and they actually have Baylor actually now pretty advanced, and
I'm Andy Anderson.
Are you from?
So
Anderson has
it's
to too.
it's-
They actually tougher to work with, a little more tougher to work with. But Ron Dalpino has companies before, right? And Jim Welsh, the head of radiology, has companies. And so, you know, the Jim Ellison's wife working on CAR NK, right? So those are all have company affiliations, I think. Yeah.
You can also talk to VCs first,
Yes.
right?
Yeah. You can also talk to VCs. You can talk to me too. Yes.
It's real nice to see you back again.
Yeah.
For you youngsters, as I've kind of reserved the question because they just want you to have plenty of opportunity. Back then, I mean, 30, 40, 50 years ago, Nancy was so respected, so loved, and she still remained at the same kind of a charm.
Thank you.
Happy to see you back. But anyway, that's the leading question. As a chemical engineer, and then when you become a lawyer, you
Yes.
and I personally witnessed how Nancy grows and Nancy, and I personally led 3-4 billionaires to want to invest on her company, so I can see she's really good in doing the 30-second elevator pitch to 3 hours as forward. Considering that today's everything is AI, and that impact as far as the 30, 40 years your journey is probably going to be different. And to answer this young man's question, before you talk to any of us, either Baylor or MBS, talk to the sketch, talk to the world, particularly Elon Musk, the girl will be a really good start on that. And they would probably do a business model for you in 30 minutes. And that gives you the good platform, and you get operate before you reach any of those so-called experts on that. So my question to you is that, does that if AI, I know you've been from a scientist to a professor, to an entrepreneur, to a CEO, to a private equity fund, to a venture capitalist. I personally see a dozen of companies up and down, they disappear from after they, particularly biotech company. I'm pretty sure you have a lot of good feeling and bad feeling. You have your up and you have your down.
Yeah, of
Now,
course.
if you look back, if you were their age, again, would you do the same thing? And also, second question is with all this strong impact of the AI stuff is on that, would you do things differently?
Whether I will do the same thing. I knew that I probably won't be staying as a professor. Whether I can build the same company, similar one, it's hard to say, because I actually do believe my ex-husband, Say Wen, is a genius. He may not get a lot of credit. He should have, but the man is a genius. He has many ideas. And those ideas, I was the wife to execute it. And, but he had great ideas. And Xolair is one of them. So I will never said it's my idea. It was his idea. In the middle of the night, just dream and tell me about it, right? And so it is. And in terms of AI, I think AI is going to be really impactful, but I think impactful in drug discovery and all this is still too early. I think you had some experience of AI and came out that it's not so accurate. And so AI is still early in that sense. But I actually do invest in some of the AI companies, and the young lady that run the fund, the reason I gave her money is because she just think differently. I just thought I'll try, give her a chance. And she worked right now at her project, getting very good results. So you all know the T cells recognized on the HLA restricted context because TCR. And we do have through AI the ability to broaden up that coverage. How impactful it's going to be, I don't know, but it looks like interesting. So there's something. But a lot of people saying I can use AI to create antibodies. That's a statement. I haven't seen the real data to really prove in it. But to look at the changing of a protein structure, a little bit of that, you know, using computer aid software is there, but it's not real AI yet. That's where I am right now. I think expertise still works. I think disease solving is a biology issue. You have to understand the biology. You have to understand the causative agent of the disease. And then I think it will be easier, than, you know.
But just a side comment to youngsters.
Yeah.
That we were saying that even AI is so powerful, but don't do whatever AI instruct you to do, because you'll be just one of those who will use AI. So
Right.
subject yourself to that. So do different those things. But you need to understand.
You need a really
AI
deeper.
represent the artificial.
Yeah.
AI also represents the average. Anyone can have access to it. So what you know or learn from AI, everybody has equal access to. So you got to do things different from what AI or the cancer, and then you become unique. And most of the researchers or the private equity fund examiners, so they're going to look at that. This is a that they have product, so you can check out. So we do in a lot of private equity fund too. We look at it. Yeah, AI is the baseline. So you got to know what you do,
Right.
but you got to do things beyond that level. And beyond that level, just like Nancy said, that you need to show with passion. You're not just feeling mechanical, you're really just what kind of generative intelligence that we have your heart in that. And that you cannot convince yourself or people around you, you're not going to convince that people will put money in technology in order to come by. My follow-up question to you, you're so successful, you got your name, your reputation, your credit. How you allocate your resources?
I'm still reading science paper.
Money?
I'm still
Oh,
reading
what
science
makes you the
paper.
happiest?
Well, still reading science and understand science make me the happiest. Yes.
I could follow up. I think a couple of other people have kind of hinted at this, but I'm really curious about how you think about risk. It seems like risk taking in particular. It seems like this biotechnology is, as investments go, I know it's like one of the riskier areas. Are you someone that sort of goes all in? Do you hedge your bets, or what are your thoughts about risk?
Entrepreneur does not take risk like what you think the risk. We take very calculated risks. Okay, in life, if you can control your life and have the company, it's not that much risk that you're taking than at the university and let the President Trump cut your budget. Right? I mean, in reality. And so entrepreneurs take very calculated risks because we know that, you know, that's all the money you have and you spend it carefully. We don't demand, for instance, many years when I was an entrepreneur, I don't pay myself anything. I may pay people, employees salaries, but for us, we a lot of times do that. And if you can't do that, then because then for the company, you gotta do what's best for the company. If that's what you need to do, that's what you need to do. And as Gordon says, there's ups and downs.
So you say you wouldn't take a bet necessarily that if you got it wrong, it would sink everything. You
No.
need to be more conservative
No.
with your risk taking.
Right.
Okay.
Right. The risk I took at Tanox is I did took risks. I was one of the few companies that has phase 3 data before I go public. That means I took all the risk inside the company. I didn't sell it early, licensed it out, right? And if you are doing those things, like I actually met a company in which I'm helping now, they went public too early. You shouldn't do it. Why are you doing it? But they did it. Now they have a drug with really great data. The stock is in a tank. They're public. Now, how do you get the stock price up? You want to raise money, the short seller is out, and you have a dilution, the stock will go down more. You have a drug. People may scoop them up, right? So this is where the dilemma is.
I have a follow-up question. You've mentioned about how you need to have respect. You have to earn your respect in the field and you have to have credibility. So how is it important to have a postdoc as a founder or to just have a PhD?
How do you have the
How important is it to have a postdoc training?
postdoc training?
Versus just having a PhD and becoming a founder. In terms of how people look at you and the credibility and respect you from the field.
In the real sense, I think a postdoc just giving you a few more years of experience of asking critical questions. Can you ask the right questions? Can you solve a problem? PhD training is teaching you how to ask questions. MD is teaching you how to treat patients, right? The PhD is about how to ask questions, how to find the answer, how to solve a problem. All that it's important.
So you'd advise that someone gets a postdoc to get a little more training and experience in asking the right
More
questions?
important thing, if you're interested in a company, go work in a company. The real experience matters. Like this young lady was actually in a company for a few years, and then she came back and go back and be in a academic background and finishing her PhD. So that's a good way to do it too. Yeah. And then if you are interested, don't wait too long. Don't wait until you're a full professor. You got too much to lose, right? The more you wait, the more you got to lose. If you're a full professor, my goodness, you got to lose a lot. So do it when you are relatively young.
Oh, thank you so much for your sharing all the insights.
Yeah. Oh, no. Yeah.
Last question.
Okay.
Yeah, for sharing your incredible story. So I was wondering, you mentioned you have a lot of patterns and innovations throughout the business field. And wondering, as a grad student, what suggestions you would give to us in order to think outside of the box and formulate our own ideas and innovations?
You know, school is pushing very hard in translations, right? So the translations is more towards like patent applications. And the other thing is you read papers, but then you also read patents. So read patents will be one aspect you can learn as well. And so what was the real question?
Like how to train ourselves in order to be able to think outside of the box.
Thinking outside the box.
Because you mentioned that before it's impossible to make antibodies 3 grams per milliliter, per liter, and your company, your team were able to do it. I wonder how and how did you do it?
Are you a person that can connecting the dot? Do you know what I mean? Connecting the dot. If you read the paper here and you read the paper here and you see a connection between the two, it's like, voila, the new moment. So I actually involved in a project at Stanford. This is the BioX, the design program. So this is what we did. I was on the board and we trained a 35-year-old, we asked the 35-year-old chief of resident, was a surgeon. And we asked the dean of law school, computer science, aviation, chemistry, biology, medicine, all the deans, give me kid. Not the kid give me the best grade, but give me the kid can connecting the dot. We put these kids together and shadow the surgeon for 6 months. And they come back with 148 questions and suggestions. Things can be improved in the hospitals. And we had the meeting and choose from there, eventually still down to like 16 or I can't remember now exactly. Then we have a party, had all the kids that connecting the dot together and says which problem you like, and then form a team. And some of them drop out of school. But that's what I mean about thinking outside the box. So you saw a problem that you can solve, but not the way that you do it conventionally. But what would be the best way to solving this problem? And ask a few people that similarly are curious of this. And that program very successful, very successful. And the aviation group that actually built the golf balls that sold in the market can flew far away. The endoscope, wireless endoscope came out of there. The hearing aid came out of there. So there's a lot of many these such programs. Stanford is unique in that. I tried to bring that program here at the Rice. I talked to the Rice people and Baylor, couldn't make it work because it doesn't have the multidiscipline campus, and then people are generally competitors versus collaborators. Harvard couldn't do it. I was on the advisory board at the Harvard Med School trying to do there, they couldn't do it either. So it's unique. It takes an environment, but it also takes the people and the mindset. So thinking outside the box may or may not be trainable, but if you have it, usually your professor, your boss, your mother, father probably knew it, whether you are the studious students work discipline stepwise, or you're the one that jumping around and do things differently. I'm the latter part. I didn't know that myself. No one tell me. And Shiza knows when I grew up, I was as shy as you can be. You can make me talk once in a month. For 4 years, college students, a school, I probably talked to the boy in our class few times, and few of them. Many of them I never talked. But I actually have the thinking outside the box capability, but the environment in Taiwan at that time was very conservative. No one ever expected Nancy can do all this. I came out as surprised myself. So I think there is, a few people like the Baylor chairman probably figured it out. He saw me and he figured it out, right? And my boss at Centocor knows, so gave me the job. You gave the kids job and he get it done. So you give the people the job and he can get it done. Usually that person has the ability to thinking outside the box. It may be the 顽皮的孩子，比较顽皮的孩子。Okay, great.
The MD that treats patients,
Yes.
not the PhD here, but I think for the young folks, I'm a little bit on the middle
age side now. For the younger folks, I think, going back to the thinking outside the box question, is there any way along your journey that you find you're constantly going back, or outside of work, for example, any hobby or so that you try to still find a little work-life balance that maybe help you to think outside the box or to get those new ideas, or going on new path that gives you the right mindset or the courage to continue to do so?
Yeah, I would say that I am a pretty happy person. In other words, my happy threshold is very low. I can look at flowers, just isolate the flowers there and be happy myself, right? And so if you, because the threshold is low, I don't bothered by many things. The things, small stuff, don't sweat it. It doesn't matter, right? And then the other ability is probably focus. You have something you like to do, you focus on it. So that those are all sort of important personality or element that can support this kind of long journey. And ask questions and ask for help. That's another thing. Ask for help. Because people in the world want to help you. Don't be, I did want to help a Taiwanese professor. She's brilliant. But to her, data is this. You can't open. There's nothing I can do. So you want to do 3 years.
Chinese opera, full dress on stage.
Yeah, I was on stage for 3 years for Chinese opera. I did all kinds of stuff. Yeah. Very unconventional, by the way. You guys have probably listened to Beatles and Beach Boys, and I was like Chinese opera.
Thank you all for coming, and so we have a certificate for you.
Great, thank you.
And a gift.
Oh, thank you.
So do you guys want to?
Yeah, we can have a group photo together.
Yeah.
Everyone please come to the stage.
Thank you.
都选采访为了杨老师，我太太特别是不是希望感受？Senior, someone gonna help.
Please be closer. More.
Maybe 3 layers? Yeah, maybe.
I just look to I would go there.
In the front.
Maybe a few more in the front.那是真的唱好剧嘛？
对，我唱。
你唱哪个角色？评剧啊，哪个角色呢？
青云花旦。
哦，青云花旦。这个大花脸，好了。
那我为什么？
生活多彩多姿啊。
1, 2, 3. Let me try.
下个月有几个好戏。
Okay. Okay, good, good. Thank you, everyone.
都来 Houston 吗？没有，一个在加州。
一样了吧？那是这辈子也孙子孙女的。
所以要跟你照张相，你帮我照相。
你有很多粉丝都想来，但是
啊，谢谢谢谢。
但是听说没有人。
好，太好了。
快到。
Feel free to donate.
我就代为转达。哦，等一下，可以吗？好。
Thank you, everyone.
我刚刚不好意思问说，你好，我是 Steve，我在 MD Anderson 的 ICU，谢谢你好在。